So this is my video on the alternating series test. Okay. Now it says that, first of all, if a series has this following form, sigma -1 to the power n bn, right? And if the sequence bn decreases, and thirdly, if the limit of bn is equal to 0. Okay, so if all three conditions are met, okay, then we say that the alternating series test can be applied, and sigma a and bn is convergent. So for in order to apply the series test, all three of these conditions have to be satisfied. It has to look like -1 to the power n bn, and the sequence, I like to call it the accompanying sequence. The accompanying sequence has to decrease, and the limit of the accompanying sequence has to be 0. And if all these three conditions happen, then we can say that the alternating series test can be applied, and the full series, right, is convergent. All right, let's do an example. So check the convergence and divergence of sigma -1 to the power n 1 over n. Okay, so if you now first of all let's see whether this looks like the series. So we're going to compare with -1 to the power n bn, right? So the -1 to the power n is there, and there's a bn. The bn is 1 over n. Okay, so we can say that number one is okay, number two, so bn is 1 over n, and of course that is decreasing as a sequence, right? Because of n becomes large, 1 over n decreases. 3, if you take the limit of 1 over n, limit of bn, which is the limit of 1 over n as n goes to infinity, okay, that is 0, because when n becomes very large, this goes to 1 over infinity, which is 0. Okay, so all three things are satisfied. So -1 to the power n 1 over n is convergent. Okay, so for these two reasons, it is convergent. So -1 to the power n 1 over n we had. Okay, so we compared and found bn to be 1 over n, right? Okay, and bn is decreasing, and then the limit of bn is 0. So sigma 1 to the power is n by the alternating series test. So let's take another example. So now in this example, you want to check the convergence and divergence of this series. So we want to see whether we can use the alternating series test because, and it does. So whenever we have a thing like negative 1 to the power e and we try to see, so it is of that form. So 1 is correct. What about 2? So what is Bn? Bn is n over n squared plus 2. Now you know that actually the top is smaller than the bottom, right? The denominator degree is much higher than it's not much higher, it's higher than the degree of the numerator, which makes this actually a decrease in sequence. So that is correct. So 3, what we do is we take the limit of bn, and we know that the limit of bn is limit of n over n squared plus 2, and if you take the use the trick that you use the largest power in the denominator and you divide by that, you get 1 over n, and then this goes to 0, this goes to 0, so you get 0 over 1, which is 0. So the limit of bn is also 0. Or you can just see whether, because the denominator degree is higher than the numerator degree, or using L'Hopital's if you like, right? But you can always check in many ways that the limit of bn is 0. So all three conditions are satisfied. So sigma negative 1 to the power n over n squared plus 2 is convergent. So let's do another example, right? Okay. Okay, so and that is check the convergence of divergence, right? Of sigma negative 1 to the power n over n plus 1. So first of all, let's take the first condition. Well, it does look like negative 1 to the power n over n plus 1. That is correct. But if you look at the second condition, we have Bn is equal to the partner, the accompanying sequence, which is n over n plus 1, right? Okay. If you compare, this is negative 1 to the power Bn. Okay. So now we have a problem because the degree of the top and the bottom are equal. So first of all, you take the condition. The third condition is definitely violated because if you take the limit of nbn, and if you use the same trick to divide both sides, well, top and the bottom by n, and we know that this goes to 1 plus 1 over n, and this goes to 0. So the limit of bn is actually 1. Okay, so that condition is violated. So we can say that alternating series test cannot be applied. But still, that's not the answer. We need to see whether this is convergent or divergent. Well, we can show that this is divergent by the divergence test. Because why? Because if you look at the sequence of this, right, okay, and if you look at the full series, right, okay, you can try to see that if you take an to be equal to negative 1 to the power n over n plus 1, right? The full series, the full sequence, not just the accompanying sequence, but the full sequence, right? Okay. We can say that actually this will never go to 0. Why? Because see, this space is kind of going to 1, but this space will change the signs between -1 and 1. So it will go in two directions, right? Okay, but it will take the negative direction for the odd value and positive direction for the even values, but it will be heading towards 1 and -1, right? Okay, so because of that, right? Okay, this will not go to 0. But we know that when something is not going to 0, right, the full sequence sigma an is divergent by the divergence test. So the answer to the question is this is divergent, but not by the alternating test because that cannot be applied. But we use the old trick of using the divergence test because it changes signs and go to +1 and -1 depending on the even and odd nature, right? So the nth term does not go to 0, does not go to 0. So therefore, the full series is divergence. So thank you for watching this video.